Okay, so one of our most useful continuous distributions is our normal distribution. Okay, and as you can see the shape of it there. Okay, I guess the key things, anything to do with a large group of people or population, things like that are normally distributed. The key one for us, our exam results and study scores are all manufactured to fit a normal distribution. So key attributes of our normal distribution are no different from any other distribution, and that is, I guess for these ones in particular, if it's normally distributed, we say the variable is normally distributed with a mean of mu and a standard deviation of sigma, which makes that, of course, the variance. All right, so it's symmetrical. It's symmetrical about the axis, so you can see there that side's the same shape as that side. And in fact, when we start talking about area under the curve, the distance there between 0 and -1 is the same as the distance there between 0, well, not the distance, is the same as the area between 0 and 1. There's the rule that explains what our standard normal distribution is. We very, very rarely deal with the rule, okay? I guess all we need to know is that our maximum value here is dependent upon the standard deviation. And obviously there you can see that the bigger the standard deviation is, that sigma value there makes this 1 over smaller, which means if we have a big standard deviation, the spread of our data is larger, which means that peak is smaller, all right? There's our mean there in the middle every time, all right? So the mean, the median, the mode are all the same for our normal distribution. As with any continuous distribution, the key thing, the area between negative infinity to positive infinity is 1. So the total area under the curve is 1, all right? Just some things worth comparing. The location of our normal distribution is at center, which is mu. And obviously in this case here, you can see that mu2 is greater than mu1, all right, which makes it further to the right along the axis. They have the same sort of spread, so my standard deviations are the same. As opposed to, in the second one here, the center of both graphs is the same, so the means are equal. However, the blue one there is more narrow, it's got a higher peak. So because it's more narrow, it means it's more condensed, so the standard deviation is smaller. And you can see that there. Sigma 1 is smaller than sigma 2. So in terms of an example, just to highlight those, let's get a pen working. So whenever we do a normal distribution, we always do a diagram. So if I'm going to do normal distribution 1, that's a really bad one. So that's got mu1 there, and it's got a certain standard deviation. Well, how does it compare to the second normal distribution, which has a larger mean? So the center's over here somewhere, and the standard deviation is smaller, so it's more compact. So this one might look like, it might go taller and more narrow, okay? So it looked very badly drawn, but that's pretty much. So have a look at those questions, I guess. Have a look at those questions just to compare standard deviations and means and different distributions, all right?